Good morning, everyone. Can everyone hear me? All right, guys. Good morning. Hope everyone is doing good. So we'll wait a couple of more minutes, guys, for people to dial in. Right? We'll start in 2-3 minutes. All right, guys. Let me start sharing the screen. All right, guys. Let me know if you see the screen, right? Can everybody see the screen? Awesome, guys. All right, welcome back, guys, with the Basecamp sessions that we are getting continued. So in the last session, we talked about the data visualization capabilities in Python, how we can plot different graphs, how we can tweak some of the attributes and some of the properties of the graph, and how the visualizations can play a very important role in terms of telling the story behind the data. Okay, and we are going to continue the same today. However, the flavor would be different. What we call it as a descriptive statistics. Okay, this is a very important concept in the first phase of your machine learning journey. Okay, so let me give you a very simple scenario. I'm sorry. When you start working for any of the client or on any of the machine learning problem, the first step that you will have is the data. Okay, now it is quite obvious that you will not be very familiar with the data set, isn't it? You don't know how big the data is. You don't know what are the properties behind the data. So in order for you to become familiarized with the data, that what is it all about, what is the distribution, or what are all actions can you take on that data, is determined using a simple step, is what we call as a descriptive statistics. Okay, have you ever heard, have you, I mean, I don't know, how many of you have actually learned statistics in some detail, maybe in your past experience, or maybe in college, or maybe in school? Any experience with statistics? Anyone here with the statistics? Okay. So in general terms, statistics can be categorized into a couple of categories. Okay. One is a descriptive statistics and second is inferential statistics. Okay. So what do I mean by descriptive statistics is, as the English meaning or as the English name goes, descriptive, it helps you describe your data. Are you getting my point? Descriptive statistics helps you describe your data. Is that clear, guys? That is the name derived as a descriptive statistics. Okay. In another word, is there any single number or is there any single point of number which can describe what has happened with your data? Right. That is what we mean by a descriptive statistics. In interview, you might get a question. Tell me the different types of statistics and what do you understand by those different types of statistics. Okay, so your simple answer would be there are two types of statistics, descriptive and inferential. Descriptive statistics helps you understand and describe the data, what has happened in the past, because understand guys, you're describing already what has happened. So you're already talking about what has happened, what are the events that has took place in the past. And there is another type of statistics called inferential statistics, which simply means you're inferring or you're trying to generalize what has happened in the past. Can it also happen in the future? Is that clear, guys? The difference between the two. Inference statistics talks you what can happen in the future considering what has happened in the past. Okay, so there's a broad category between the statistics. So today we are going to talk about the descriptive statistics. So can everybody open the Basecamp session that you have already uh, cloned in your machine? And today we are going to talk about the day 6, understanding the descriptive statistics. So when you click on it, you will have two things, again, a data and a notebook. If I go in data, there will be a file called train.csv, and then will be our notebook. So I've already opened a notebook for my reference. Has everybody opened the notebook, guys? Quickly. Have you all opened it? Awesome. Let's talk about it then. Understanding the descriptive statistics using a Titanic data. I'm sure everyone knows what is Titanic and what happened with Titanic. Okay. Again, Titanic data set is one of the most widely used data set in machine learning industry. It is freely available. Okay. So the sinking of the Titanic is one of the most infamous shipwreck in the history. On April 15th, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1502 out of 2224 passengers in the crew. Okay, so out of 2224 passengers in the crew, 1502 people died unfortunately because of there was no enough lifeboats available. I'm sure everyone knows the history and I'm not going to go into detail of it, but this is just some, again, a descriptive statistics to talk about. While there was some element of luck involved in surviving. So when you look at the data, okay, you will come to know by end of the today that not everybody who survived was survived because of quick action or any other sort. There was another element was a luck who got survived. Okay, we'll talk about it why the luck element came into the picture. Okay, it seems some group of people were more likely to survive than others. Okay, from the data that we have available in the internet, if you study well, you will come to a conclusion or you will realize it that there was some group of people, right, who were more likely to be survived than others. Let's go through the process and understand the basic descriptive statistics using this data set. Okay. So again, traditionally, what we are going to do is we are going to import the libraries. So import NumPy as NP, Pandas as PD. So we should be very much comfortable with these two libraries for now. Second, we are going to plot the matplotlib.pyplot as PLT, which we looked at yesterday, or we got introduced to this yesterday. And the new library that we are going to talk about is import Seaborn as SNS. So Seaborn is an advanced Python visualization library which is built on top of matplotlib. Okay, there are some benefits of using Seaborn, like if you want to create a 3D graphics or if you want to create 3D plots, then Seaborn is your choice. Matplotlib does not allow you to create a 3D plots. Okay, the color variation, the more sophisticated plotting is available in Seaborn rather than Matplotlib, because Matplotlib is a pretty older library. However, Seaborn is a very new generation library. So the number of plots that you would see in Seaborn is far more better than the number of plots you would see in Matplotlib. So we will introduce what is Seaborn, how to use it. Okay. Can we quickly import the libraries, guys? And can you quickly confirm that everyone is able to import the library? Quickly. Have you all imported, guys? Awesome, guys. Good. The next obvious step for us is to read the data. Okay, there's some error. Okay, Ovi, what is the error that you're getting? People might get error in the Seaborn. That's why I asked, can you import it quickly?
No module named Seaborn.
Yeah, so you'll have to install the library OV, right? So what you can do, so people who are getting no module error, as you call recall, in order for you to use the library, there are two-step process, right? The first step, you have to install the library. How you install it? You can simply say exclamation mark, pip, install Seaborn. Okay. It's simply you have to install the library on your machine. So when I run it, so for my case, it is already installed. So it will tell me requirement already satisfied. But what is important for you guys to look at it is built on sci-fi. It is built on top of Matplotlib, NumPy, Pandas. So these are the four important library on which this library is built upon. Okay. And once it is installed, over you can simply write this statement, import cbon as SNS. Okay. The people who have imported the libraries, let's move on with reading the data. So again, we are going to extend the help of PD, that is a pandas data frame. And because my data set is into CSV format, that is comma separated values, I would simply say PD dot read underscore CSV. Okay. And it simply asks for a data file name. So I'm going to say under data folder, go to train.csv. And if I run this, my df object will now hold my CSV file. In order for me to have a quick look on my data, I would simply say df.head. Can anybody remember what df.head does? Quickly.
The initial lines is read scene.
Absolutely. The first 5 lines will get printed on the screen. Okay. The very first 5 lines will be printed on the screen for me. If you see this is 0 to 4, those are my row indexes and these are my columns. So if I quickly see, I have columns like passenger ID. Then I have an important column called survived. Okay. The 0 simply means he didn't survive or she didn't survive. 1 simply means this individual was survived. Okay. Then you have a PC class. Now I think the PC class talks about what is the class of coach or what is the class of room that this individual was stayed. So in our flights, in our trains, we have coaches, right? Sleeper coach, AC1 coach, AC2 coach. So this is what it is. Then you have the name of the individual. You have the sex of the individual, age, SIB SP, we'll talk about this, don't worry, and the parch. So this is more to do with where this individual was stayed. Okay. So it is trying to give you an information about the stay or the deck in which this individual was staying. Then you have a ticket number, which is I think not relevant to much extent. Then the fare that this individual paid. Okay. Now you can, by just looking at the first 5 records, you can clearly see that there are some fares which is in $7.25. However, there are some for you have paid $71. So there's a huge difference here, right? There are again 53, there are 7 and 8. So my point of saying here is the way you should read the data is quickly in these terms. That the first couple of records are giving me the fare in the tens unit, like $7, 7s and 8. There are also the records where I have in the 100 unit, like 71, 53 and so forth. And then I have a cabin and embarked. Okay. So this is a pretty much broad group of columns I have. Okay. The very important step, if you want to get a clear understanding of your data, is using a simple inbuilt function called info. Again, it is called upon the object of data frame. So df.info. Okay. So info will print every important information about your data frame object. So let's read the line by line output and let's try to understand it. The very first line, it tells you the type of the object. Can we quickly see what it is? It is saying me pandas data frame. So I know that the df object is of a type data frame. Then I have another line which tells me 891 entries 0 to 890. Can somebody tell me what it is quickly? What do we mean by this line?
It is giving the total number of records with the corresponding index.
Absolutely right. So this tells me I have total 890 records available in my dataset. Okay. It says 891 entries because I have a column headers as well, right? So this is the first, and then I have 890 records. So the original data I have is 890 records. I'm just giving you a flavor that how you should read or how should you interpret this info output. Okay. So this tells me I have 890 records. I have a total 12 columns, right? So imagine you're working on the data set for the very first time, like you're doing it now. How easy it is for me to get this information, like 890 records, 12 columns. If I go down, I get a column wise information. So if you see here, the first is a column index from 0 to 11, right? So that's a 12 columns I have. Then I have the names of the columns like passenger ID, survived, and so forth. And then I have a non-null count. Okay, I have a non-null count. So what it is telling me, 891 non-null, 891 non-1. Can somebody tell me what does this mean? Or what does this mean? Why I am seeing a number of difference here? Anyone want to make a wild guess?
Age of others are not known. Null.
So Shiva Lakshmi is absolutely right. This tells me I have some null values available in age column. Similarly, I have some null values available in the cabin column. Because if I don't have any nulls, then my non-null count should match with my total entries. Is that correct? Bilal, just give me 2 minutes. Let me finish this and we can come back. So if my data does not have any null, then it should match the non-null count with the total number of entries. Correct? So here my number doesn't match. That clearly tells me that this particular column has a null values. So again, in a very brief movement, I understand that some of my column already has a null values which I have to deal with. And the very last column is again a very important information. This tells me the data type of my columns. So passenger ID is of a type integer because I have all the numbers. Similarly, survived is integer. PC class seems an integer. The name is object and the sex is object. Can somebody tell me why quickly? Why do we see name and age as an object? Quickly guys, why do we see as an object? We have already talked about this.
Strings.
Absolutely right. Pandas,
String.
absolutely right. Pandas consider everything as an object which is not a number. Okay. So whatever is not a number, that would be considered as an object. My column name and sex has a characters, has a string into it. That's why it's considered as an object. If I go to age, I get it as a float because it has a decimal point numbers. Here it's a brief summary again. I have 2 column as a float, 5 column as integer, and 5 column as object. And the total memory that it is occupying is 83.7 plus KB. Okay. So this is a very important piece of information or too many pieces of information you can easily capture using a dot info method. Is that clear guys? Any quick question on this? Anybody has any question on how to interpret this information? Because trust me guys, when you start working on any problem statement, you might want to do this dot info at the very beginning step to understand your data well. Are we all clear guys? Cool. So take a moment to digest it. Till the time I can just talk to Bilal and see what is the error. Okay. So below you are getting invalid argument error. The file path is wrong. Bilal, you want to recheck the file path.
Let me recheck. Thanks.
Yeah, because it is giving invalid argument. So this is the simplest way you can do it, guys. This is the simplest way you can read it. The first two dots will take you out of the directory. Then you go to the data directory and just give the file name. Everybody is able to do it. Avi, have you solved that error? Are you able to read the file now? Cool. Let's talk about the first topic here. So I assume that not many of you have covered the statistics maybe in the past, right? But let me ask you very first question. Do you believe that whatever data we work with has all the same properties, or they're all same in some manner, or they differ in the way they are created or the way they carry the properties? What do you think? Do we have only single data type, or do we have multiple data types? Absolutely right. We have different types of data because we, in the real world, we have a multiple properties of the data sets, which we cannot possibly have it or hold it in a single type of data. Okay. So there are potentially four main types of data. Okay. Let's try to understand them. Okay. First is a nominal data. Okay. First is a nominal data. The values fall into predetermined categories and cannot be sorted. Okay. So if you closely observe, we have a distinct categories of the values which you cannot sort, or basically there are no logic behind sorting those numbers. The following columns are nominal in the Titanic dataset, like sex, embarked, and survived. Okay. So in a very simple sense, can I say that male is greater than female, or can I say female is greater than male? Can I say that in any way? Can I do a logical comparison between the two? Or can I say maybe red is greater than green? Or can I say green is smaller than black? We cannot do that. Okay. However, we categorize our data sets into predetermined categories like male, female, right? Colors like red, blue, yellow, or whatever it is. Is that clear, guys? So we have a different categories, but you cannot sort it. That's what we call as a nominal values. So if you look at here, the column like sex, if I have male, female, I cannot sort it. Similarly, I have a survived, right? Because this is a numeric column if you look like, but this is a nominal value, because if I survived, I will convert it. 0 means survived. Sorry, 0 means not survived, 1 means survived. And I cannot say that which is greater, which is smaller. Okay. Similarly, if you look at embarked, I have S, C, S, S, and I cannot say if S is greater than C and C is greater than S. Okay. That's a nominal value. Second type is an ordinal value. Okay. The values can be sorted. However, there is no scale. Again, values can be sorted. However, there is no scale to it. PC class is the example of it. So PC class is one of the example of it. Very simple example if I can give you, if you look at the clothing sizes, I can say that L is greater than M but smaller than XL. Are you getting my point? XL is greater than L but smaller than double XL. I have an order there. I can put it into a specific order. But do I have a scale there to measure it? No, I don't. Is it making sense, guys, what I'm saying? You can sort it in a specific specific format or specific sequence, which describes the, what you can say, the quantitative greaterness or smallerness, but there is no specific scale for it. Are we clear, guys? What is the difference between a nominal data type and what is the ordinal data type? Any confusion here before we move on? Yes, guys, any quick question? The third one is an interval data type. Okay. The values can be sorted and there is also a scale available. Okay. The difference between ordinal and interval is you can sort the values and you also have a scale to it, but there is no 0 point for the values. So there cannot be a 0 point. So column with temperature measurement in a data set could be an example of the interval data type. So whatever data type that you might want to work with, you can definitely put it into a differential sorted sequence, but there will be a never 0 point. Okay. The best example for that is a temperature. Okay. A lot of time you will say there is a 0 temperature, but that is not a right statement because there will be always a temperature to it. You cannot put it as 0. Okay. So, and you have a sort there. I mean, you can put it into a sorting. So you can say temperature 1 is lesser than the temperature 2, right? So you can sort it. And the last is a ratio. The values can be sorted. There is a scale and there is also a 0 point for the value. Okay. So there is a there is a column or there is a value which you can definitely sort. You have a measurement scale or you have a quantitative scale, but and you also have a 0 point where you have a definite 0. So the examples are age, right? Example as fair. So when I say someone's age is 0, right, that makes sense because he's not even maybe just born or something like that. Or when I say fair is 0, that simply means I have got the free ticket. So that's a logical 0 that can exist. And when I say sorted, you can simply say maybe age 15 is greater than someone who's age 10. Does that make sense, guys? So you can sort, there is a definite scale, and you can also have a 0 point. That's the ratio data type. So these are the 4 important data types that you will find when you talk about the statistics. Okay. And every 4 data types that we just talked about have a different properties, have a different way of representation, have a different way of studying them. Because the way you study the nominal variables, you cannot study the same way the ordinal variables because the properties are different. The way of representation is different. Are you all clear with this, guys? What is the basic data types? Any question, any confusion, any concerns? Quickly. Any more example of an interval? I think, let me check for you because I think the most important examples are the temperature only. Example of interval data in statistics. An interval scale is a one where we have order. The difference between the two values are meaningful. So example of interval variables are temperature Fahrenheit, temperature Celsius, or you have a SAT score 200 to 800, credit score 300 to 850. So let's talk about it. Let's maybe look at the example. Let me share this link for everyone's reference. So if you see here nominal data categories, but you cannot order it, there is no direction. If you talk about ordinal data, then you have ordered categories. You can rank it, you can order it, or you can scale it. The interval is differences between the measurement. Okay. So ideal way of saying interval is the difference between the two measurements, but there cannot be true zero. You cannot have a true zero. The ratio data is between the two measurements, true zero exists. So let's look at it. An interval scale is one where there is an order and the difference between the two value is meaningful. Example of the interval variable includes temperature Fahrenheit, temperature Celsius, maybe your SAT score, which is between 200 and 800, or maybe a credit score where you're between 300 and 850. And the ratio is of ratio variable has all the properties of interval variables, also has a clear definition of zero. So when the variable equals to zero, there is none of that point. Okay, so example of the ratio is enzyme activity, dose account, dose amount, reaction rate, flow rate, concentration, pulse, weight, and so forth. That's a real number. The real zero exists here. I can say my weight is zero. Okay. If you see here, temperature in Kelvin can be zero. Okay. Because I think Kelvin is the method which tells you there is no heat or something like that. But in temperature in Celsius and Fahrenheit, you cannot have an actual zero, true zero. I hope that makes sense, Prasad, by any chance. Right? All right. So once we understand the data, there is a very, very important concept in statistics, which you will use very frequently when you come to the ML side in your journey, maybe the next step. So understanding the central tendency of the data. Has anybody heard this term before, central tendency? Have you learned it maybe in your previous modules or in any other form? Okay, Prasad has learned it. Anyone else? Any idea about what is central tendency? So Kamlesh, no. Okay, no problem. Anybody else? Okay, that's a mixed answer. All right, cool, no problem. So central tendency is one of the very important element of a descriptive statistics. Okay, and let me tell you very straightforward meaning of it. The central tendency, if you look at this word, central tendency, it simply tells you, do I have any central number using which I can describe my entire data? Again, I'll repeat one more time. Do I have any central number that can describe my entire data set? Is that clear? So the idea behind central tendency is finding out one number or finding out one element that can talk about your entire data set. So for interval and the ratio data types, we can describe the central tendency of the values. Central tendency can be described using the three concepts: mean, median, mode. I'm sure we all have learned this. We all know what does it mean. Okay. Mean is calculated average of the values. Median is the central number, the median value, the middle value, in another format, and the mode. So mode simply means the most number of occurring values or most frequent value. Are we all clear with this mean, median, mode? I'm assuming we all know what is mean, median, and mode. Maybe in the schoolings we have learned it in some other flavor, right? So why this three falls under a central tendency? If you visualize it, if you think about it for a second, you will realize using these three numbers, right, in individual manner or in alone setting, I can still describe my data. Let's say if I give you, or let's say I give you a marks of 100 students, and I tell you the average score of the students is 70. Will you be able to visualize, or will you be able to make quick assumption that what would be the students' marks in a way? Yeah, can you quickly make inference out of it? Can you quickly make assumptions that what would be the marks that students would get? If I quickly tell you that, in the batch of 100 people, the average score is 70, right? So I know that majority of the students have got 70. That's how I can use the mean and talk about my entire data set. Median. If I say the median value of the scores for 100 student is 60. So it means the central point or the middle value in the score is 60. And if I say the score or the mode, right, the mode of a score in the batch of 100 people is 71. So can you make a quick assumptions, or can you quickly understand how your data could look like? Is this? Are you able to visualize it? Are you able to make any sense out of it, that why mean, median, and mode falls under a central tendency? And do you visualize that using these three numbers, you can easily visualize how your data could be, or what would be the distribution of your data? Are we all clear with this, guys, before we move on? Because this is the most important concept, and I'm sure you will get it in your interview for sure. The simple question the interviewer has is, what do you understand by the central tendency? And can you tell me some of the important elements of a central tendency? The simple answer is mean, median, and mode. Should we move on, guys? Everybody's clear with this? Any question anybody has? Bilal, let me complete this because it's pretty simple. You just have to read the file, and we have done it multiple times so now. You can do one more thing. You can just copy that file and paste it to some other location and try to read it. That you can do. Put that file somewhere else and read it to that location. Sure. Till the time everybody else can try this, can we find the mean, median, and mode for the variable age? Can everybody try this? Yes, guys, can everybody try this? How do we find the mean, the median, the mode for the variable age? Yes, guys, can everybody try? Anybody found the answer? Anybody can tell me how you find it? Yes, guys, anybody tried it? The simple thing we can do it is df the column that we are interested in. So df age dot mean. Okay, simply df age dot min. I can store it in the variable if I would like to. The mean age, so the mean value for the age is mean dot format, mean is equal to mean age, and I get 29.69. So can we quickly make any observation that how the age or how the passengers would have boarded the Titanic? So we look like, or it seems that majority of the passengers was young, around the age of 30. Can we say that? Can we say that the majority of the passengers were the young passengers around 30 of the age, right?
Yeah.
And if I talk about the median, it's pretty much similar to what we did as a mean. So df column age, then dot median. And if I print it, the median, it's simply 28, which makes sense because my average age is 29.69 and the central number in the age is 28. So the property that makes your data absolutely a normal distributed data or absolutely wonderful data is your median and your mean should be close enough. Okay, your mean and your median should be close enough to each other. Okay, and lastly, if I have to check the mode, it's simply df of age dot mode, right? The mode value for the age is 24, right? So it simply tells me that the most frequently appeared number is 24 in the column age. Are we all clear, guys? What do we do here? What we did here? Any quick question? What is mean, median, mode? How we calculate it? What is the difference between the mean, median, and mode? Now, as we understand that the statistics has a descriptive statistic has a two coins or two side of it. One is a central tendency, and second is the dispersion of the data. So central tendency helps me understand my data with the just single point of number, like mean, median, and mode. That is single number, right? This is a single number I'm getting. Again, this is a single number I'm getting, and again I'm getting a single number here as well. But using this single numbers, I can still make the assumptions. I can still try to understand how the column age would have been at that particular point, right? What are the properties of the age column? So that is what we mean in the central tendency. The second element in the descriptive statistics is we call as a dispersion of the data. So the English meaning, if you look at the dispersion, it simply tells you how my data is distributed. I'm getting my point. How my data is distributed. Bilal says my issue is resolved when I use double slash instead of single slash. Google showed this description. Well, Bilal, this similar issue that you are reporting is pretty much we have covered it in the very first lecture, if I'm not wrong. The double slash and the single slash. Second, it again depends on the operating system to operating system because the similar thing is working here. Right? So again, the point is the character issue, the slash issue. If I'm not mistaken, we have pretty much in depth covered in the very first lecture when we started. So I was under assumption that by now we are pretty much clear how to use this slashes. But anyways, I'm happy that your issue is resolved. All right. As I was saying, the dispersion describes how your data is distributed. Okay. So there are important elements that can talk about the distribution of my data. The first very important element is a range. What do I mean by range? The range, I simply mean what is the minimum number and what is the maximum number for that particular column. Because if I know what is the minimum and maximum, I will understand that how is the range of my data, right? How my data is distributed between the two values. So if you are working with column age, and if I tell you that your minimum is -10 and maximum is 200, do you believe that is a valid number? Or do you believe that that number is authenticated? Or that is a legal number to use? Does anybody believe that? Well, clearly no, because age cannot be or cannot have a negative values, one, and second, you cannot have probably age more than 150 or 110. I'm not sure, but yeah, the range helps you understand what is the mean and the maximum values your column has, and if there are any discrepancies that you find out in the age, or sorry, in the mean and max, you can easily report it. Okay. Second is the variance. Okay, very important element. What is variance? Variance is sum of square distances from each point to the mean, right? It is the sum of squares of the distances between every single data point to its mean value. Are we clear what is variance, guys? It tells me what is the accumulated, or what is the, what you can say, what is the total difference between my every data point to its mean value. So the mean value of age is 29, correct? And the first value I have in the age is 22. So what I would do is the sum of square distances is 22 minus 29.69 square. I will keep on doing it for every number in the age. So 38 minus 29.69 square. That is why I use a word sum of squares distances. Is everybody clear what do we mean by variance, guys? Anybody, any question what is variance? Guys, quickly, any questions anybody has in the variance? What is variance? Are we clear what is variance? The standard deviation. The next point is the standard deviation. The square root of the variance. The square root of the variance is the standard deviation. Standard deviation is a widely used because unlike the variance, it is expressed in the same units as the values. However, the variance is expressed in a square units. A lot of people have this question that if we already have a variance, which is telling me the differences between the data point and its mean, why do I need a standard deviation? The simple answer to that is the variance is talking about the differences in the terms of square unit, because I'm squaring it off. So the units or the measure in which my individual values are, like the age column, and the value that I would get in the variance would be very different. The scale would be very different because I'm squaring it in the variance. However, I need a simple measure which talks or which is in the same scale as my normal column. That's why we use a standard deviation. So I'm simply doing a square root of the variance. And standard deviation is the most fundamentally used measure in descriptive statistics as well as in the machine learning as well. Every algorithm that you will learn, maybe in the future, you will see how important a standard deviation can be. And lastly, we have a quartiles and interquartile range. The data points can be divided into quartiles. What do we mean by quartiles? Anybody has any idea? What is quartiles? All right. The quartiles are nothing but you can divide any data set into 4 parts. The first quartile splits the lowest or a 0 point to the 25% of the data. The second quartile can divide the data between 25% and the 50%. The third or the highest quartile, the fourth quartile is 75 to the highest value. Okay. So basically any column or any data set that you pick up, you can divide it into 4 quartiles. First quartile, second quartile, third quartile, and the fourth quartile. Okay. So 25% of the data from the highest, right? So that is what it is. The second quartile, Q2, cuts the data set in half, and the third quartile splits the highest 25% of the data. Right? So these are the 4 very important elements that talks about the dispersion of the data. This 4 element helps me understand how my data is distributed. So let's calculate the range, the variance, the standard deviation, and find out, visualize the quartiles of the variable age. Can everybody quickly try it? I was trying. Anybody trying? Okay, Ravish is done. That's awesome. That's good. That's good. That's nice. So Ravish, Shivalakshmi, as you are done, I would request if you can try to interpret those values and understand how it is related to the column age. Can you make any inferences? Can you tell a story about the column age using these numbers? Because that is what very important is. I mean, finding mean mode median is a one part like we did here. The another very important element of it is how do you build a story or how do you tell a story about your column age using this number to your stakeholders? How do you explain how the column age is distributed using this number? That is very important. Anybody else is done? Still trying? All right, let's look how we can do it. So the minimum and the maximum I can easily find out using a same mechanism as df column age dot min df column age dot max, right? So using these two inbuilt function, I get min and max. Okay. There's a question from Akshara why we use format, but it's just a way we can introduce the static element of the print with the dynamic element of the variable. Is it clear? So if you look at it, the sum part of my print statement is static. So this part is not going to change, right? The minimum value of age. So this part going to be remain as a static. However, this particular portion is going to change all the time. Is it clear? So if I want to utilize the static part as well as the dynamic part, I can use the format. It's not just this way, there are multiple ways in which you can do that. However, the most efficient way is using a dot format. So basically, it's what we call as a formatted print statement. Okay. So I'm just saying the minimum value for the age is then this, and the maximum value of is this. So I'm introducing the variables with the static part. Does that make sense, Akshara?
Yes, Puneet. I tried without format also, but it's printing the same value. Is there any
So you're using without format, right?
Yeah, I tried without format. It's printing the same value.
So it is still working, I'm saying, right?
Yeah, yeah.
Absolutely. So that's what I'm saying. You can print it without format as well. Okay.
Okay.
However, when you have a format, you can assign this values like in this format. So why we use format at many locations is, imagine I want to print maybe 20, 30 values. Okay. So I simply want to keep a track so I can use it in the dot format.
Okay.
So that's the only reason. It's okay. If you use it without format also, there is nothing wrong in it.
Okay.
Okay. So if you quickly observe the data here, the minimum value of age is 0.42. Now this looks a little fishy, isn't it? I mean, I cannot have age definitely in this format, like 0.42. Have we ever heard that someone's age is 0.50? Right? We can't. So we clearly see that there is some pre-processing would be required for the column age. Because if we pass like this values to our machine learning model, it would be very difficult for any model to make any relationship because the data looks pretty much wrong in itself. So this is something I was trying to say, Ravish, that you want to build stories around the results that you get. Okay. The easy way to find out a variance is df of age dot var, that is where, which is a short form for the variance. Now, if I print it, I get 211. So the point that you see here, that the variance is expressed in the same unit as the values. The variance is expressed in the square units. So the moment I was saying the unit of variance is far more different than the unit of a particular column. The scale, the unit of my column age is between hundreds. So 0 to 100, because I see that, right? From 0 to 100 maybe. However, the variance value that I'm getting is in the 200 range. So definitely the scale here and the scale here is a very different. Can we observe that? The scale here and the scale of the same variance is pretty much different. So I will not be able to efficiently utilize this information in any of my further tasks, like creating models or maybe understanding the data. But I cannot do that because the scale is different. That's why we need a standard deviation, right, which will convert this particular scale to the scale which is in which the column age is present. So if I simply say STD, that is the short form for the standard deviation, right? I can simply say the standard deviation for the age is 14.52. Now, yes, the scale of this particular value is pretty much the same as the scale of this value. Guys, does it make any sense? What are we trying to say here? Is it making sense? What is variance? What is standard deviation? How you interpret them? Why we need standard deviation if variance is already present? Any quick question, guys? The variance of ages, where? That is what it is, right? Oops, okay, there's a spelling mistake. Is it right? Thanks for pointing that out, Ramesh. Any quick questions, guys? Are we all clear what is descriptive statistics? What is central tendency? What is dispersion? Any quick question, guys? Okay. If there are no questions, then let's break for 10 minutes, right? Then we will come back and we will talk about the rest of the part. Okay. Let's be back in 10 minutes. Thank you guys. Hello everyone, is everyone back? Shall we start? All right, let's talk about some of the important methods that we're going to use of pandas data frame. So use the describe method of pandas data frame. What are your observations for all the variables? How should we handle such records? So Shivalakshmi, there are many ways you can do that, but I'll tell you some of the important ones. One, you can have a word with the data owner or the person or the team who have supplied this data to you, correct? I'm saying about the typical industry scenario.
Okay.
So you can validate whether the data that you have received is valid or is some human error, typo error, right? Then you can, with the consultation with them, you can replace all these values, right? So wherever you have like 0.42 or any of those decimal point ages, you can just go ahead and replace it with maybe 0 or 1 or maybe 5, right? Maybe that is one way, which is about a replacement of these values, but with the consultation of the client or the business owners. Okay. If these records are very less in number, so let's say out of million record, you just have 5 or 10 such records, you can even think of deleting those records because it might be because of the errors between the systems. Okay. Or as
Okay.
Bilal pointed out, it can be a 4-month child. But again, this has to be consulted with the business owner saying that whether the age of 0.42 is a valid or not. If they say it is a valid age, then you can keep it as it is. You don't have to remove it because business is already in consultation saying that yes, I can get the same values. So you can keep it, no problem with that. So there are options like you can keep it as it is. You can completely delete those records, or you can think of replacing those values with such other numbers. So those are a couple of options you might have. I hope that answer your question. Right. So there is a wonderful method in pandas data frame is called dot describe. Okay. So the way we use the dot info to get the fundamental information about my data frame, similar to that, if I want to get a statistical information about my data frame, I can simply use dot describe method. Okay. So if I use dot describe, it will help me 5-point summary for all the numeric column. Okay, I repeat, dot describe method helps me get 5-point statistical summary of all the numerical columns. So if you see here, when I say dot describe, I only got the columns which are numeric in nature. Whichever object column I had is not considered. So those are my column headers. And if you look at the row wise, I have a count. So these are the non-null counts of the individual column. Then this is the average, mean. So average of passenger ID, average of survived, average of PC class, average of age, and so forth. Then I have a STD that simply tells me the standard deviation. So standard deviation for each column. Similar to that minimum, so minimum of each column. Then the 25th percentile, 50th percentile, 75th percentile, and the maximum of each column. So the point of saying is the way we are doing it for each column individually, like min, max, where, and so forth, we can do it in a single line of command for all the numeric columns. And this is what we mean by a 5-point summary. Okay, so it is telling me 5 or 7 different numbers using which I can easily describe the data that I'm working on. Can we do that, right? If I give you only this count, I can make some assumptions or I can make some inferences about the data that we're working on. And I think these are the only options or these are the only parameters we need before we make any conclusion on the data set. Isn't it right? Can everybody try this dot describe method? Done? Are we done, guys? So whatever we have done so far is primarily getting the statistics of the data or to understand how the data is distributed or how I can describe the data that I'm working on. There's another way of doing it is simply the visualization of the data. So far, we have not visualized anything. We are just getting some numbers which we want to use to tell the story around the data. But another very important way we can do that is using the visualization. Okay. So calculation of values which describe central tendency and dispersion of the data is a very useful for understanding the data. But these numbers are not very demonstrative. We all agree to that, right? We have got all these numbers, which is telling me the central tendency as well as the dispersion of the data, but it's not demonstrative. The best way to understand those values is to visualize this data. So bar charts are commonly used to visualize the nominal data. So plot a bar chart for the feature sex. So we are simply saying gender count is equal to df of sex, because that is the column I'm interested in, dot value counts. We have already looked at what value count means in the last session, I think yesterday. It will simply tell me the unique number of categories that are available in my data set along with the values or the number of records associated with it. So if I say gender count is equal to df of sex dot value counts, and if I simply say gender count dot plot kind bar, I should see something like this. So I can clearly see that the passengers that was boarded on the Titanic ship, we had a more male than a female. So we approximately have 50% more male than the total female count. Can you try doing it quickly, guys? Can you try to run this code? Are we getting the output, guys? Everybody? Histograms are primarily utilized to visualize the interval and the ratio data. Looking at histogram, we can find out the range of the data, because we know histogram will plot the minimum and the maximum. So we will know the range of the data and how the data points are distributed along the range. Can somebody try having histogram for the column age quickly? Can somebody try doing the histogram for the column age? Absolutely right, sure. Thank you so much for that. So if you quickly look at it, df of age dot plot, right? I'm directly utilizing the data frame object along with its column name dot plot kind. So I'm just saying what type of graph I want. I'm simply saying hist. So hist is a short form for histogram, and I'm just saying plt dot show. And this is how I get it. Can we see, is it normally distributed by any chance? What do you guys think? Is it normally distributed? Mhm. Can we understand some of the underneath properties of this distribution? On the histogram, we can see the age values spans between 0 and 80, right? And the most common value for age lies around this period, like I guess 20 to 30 or maybe around 30. Prathamesh says density plots better. Let's try that. Yep, you can even do that. No problem. No worries with that as well. So the important part, as I was saying earlier, guys, you need to really understand how you interpret this graph, because plotting this graph is just one line of a code, but interpreting this graph is a very difficult task. I have seen in my experience that a lot of people struggle to interpret the graphs. Okay, so that's why I'm re-emphasizing it again and again, that it's very important that you develop a practice of interpreting the graph well. Okay, now let's talk about the block box plots. Has anybody heard what is box plot before? Okay, Prathamesh has heard. Anybody else have heard what is box plot? Why we use it? Okay, okay, no worries. So box plot is the most important plots in terms of descriptive statistics. Okay, so when somebody wants to showcase all the 5-point summary that we have seen here into a pictorial format, you can easily do it using a box plot. Okay, so how you print it is pretty simple. Quickly observe, I'm not using any matplotlib now, I'm using SNS. SNS stands for the Seaborn library that we have imported, right? So we are saying SNS.boxplot. On the x-axis, I'm printing the age. So basically, I want to see the 5-point summary of the age column. And if I print it now, this is the age, this is the call, this is the plot that I get. So this line is the minimum data point, it's around 0. This line is the maximum data point. Now you might realize the maximum data in our age was 80, correct? However, the box plot showcases that the max age is around 65. So the point of saying is when you use a box plot, it internally recalculates the minimum age and the maximum value. Okay. This particular line that you see is the 25th quartile. This bit middle line that you see is the median value. Mind it, guys, this is not a mean value. This is a median value. This particular line is called the 75th quartile. Okay. So box plot and the whisker plot quartiles, the band inside the box is the second quartile, the median value. The end of the whiskers represents the lowest datum still within the 1.5 quantile IQR range or interquartile range. Okay. Data points outside the whisker are plotted as a small dots or squares. These points are considered as an outliers. So box plot is primarily used for two reasons. One, to pictorially demonstrate the 5-point data summary for any column. Second, in order for us to identify if there are any outliers in my column. What is outlier? Anybody has any idea what is outlier? All right. Well, outliers are the data points which does not follow the normal patterns of your data. Okay, it's very different than all other data points. So those are called as an outlier. So these small squares or the dots that you see here are nothing but the outliers. Okay. This whiskers denotes the smallest number. This whisker denotes the largest number. Central line is again a median, and this box is called IQR, interquartile range. What is IQR? It is nothing but the difference between the 25th quartile and the 75th quartile. Guys, is it making any sense? Because if you don't reply, I will consider that you are understanding it very well. Okay. So IQR is nothing but the difference between the 25th quartile and the 75th quartile. And in statistics, we have a simple rule. Any data point which is not falling between the 3 standard deviation distance is considered as an outlier. Okay. In statistics, we have a very simple rule. Any data point that is not falling between the 3 standard deviation distance from the mean, it is considered as an outlier. That is why any data point you see here or any data point you see here are considered as a outliers because they do not fall between the 3 standard deviation distances. Okay. In interview, you might get a question to interpret the box plot, and you might get a question, how do you understand the distribution of data by just looking at the box plot? Any quick questions, guys? Has everybody printed the box plot? Are you getting the results? We can even try with another column to understand. So I can say fair. Look at the distribution. Can you see this box plot? It's so different than what we had in the age. So this indicates that my data is in real good shape. My data is distributed well, right? If you want to validate my fair column, why it is giving me such a weird result, we can quickly check the histogram for it. Now, do you see why my box plot is generating this kind of a result? For the column fair, the maximum value I have is between 0 and 500, it seems, or 550 in a way. The majority of the data point I have is central between 0 and 100. There are very few data points that I have after 100 till 500, right? So in this range, there are very limited number of data points. And this is exactly what I can visualize it here. Does that make sense, guys? Is it clear? Can we now understand how do you interpret the histograms and the box plots? They're both representing a similar information to us, but in a different flavor. Are we all clear, guys? Okay. So the last point for today, or the last maybe important element in a descriptive statistics, is correlation coefficient. Okay, correlation coefficient. What do I mean by that? So let me maybe start with a question if you're interested in giving the answer. When we have a data set, right, when we are working on any particular data set, we have different columns available into it, right? We might have 10 columns, 20 columns, 30 columns. Do you believe that the columns that we have, these columns have any relationship with each other? So in a maybe reformed way, do you believe that the column survived has any relationship between the PC class, or do you believe the sex column has any relationship with the column age? Sanjeev says can have, right? Any other views? Right, sure, might, all right, cool. So the ideal answer is correct, maybe, right? That's the correct answer, maybe. So Sanjeev, Prasad, Bilal, you're all right. When we get a data set, when we work on any particular data set in machine learning world, it is very prominent, it is very important that we understand if the columns are interconnected with each other, or do they have any relationship with each other. Okay, so very simple column is, imagine if I have a data set and I have two columns like date of birth and age. Do you think these columns have highly correlation with each other or highly related to each other? Absolutely right, yes. Because both of this column is giving me the same information. If I have a date of birth, I can calculate your age. If I have your age, I can roughly calculate your date of birth, right? So the point of saying is, if I only keep one of this column, I will still solve my purpose, isn't it? So the basic idea of studying if there are any relationship between the two columns is to make sure you are not passing the biased information in your machine learning world. Because do you believe if I pass date of birth and if I pass age to my machine learning model, okay, is it safe to say that I'm passing the biased information, or is it safe to say that I'm passing the noise, the irrelevant information to my machine learning model? Can we say that? What do you think, guys? Can we say that? Absolutely right. I can safely say that it is a noise. It is the unnecessary information that I'm passing to my model. Absolutely right, Prathamesh. I am passing the same information twice. So that is why it is very important that before we do any machine learning task or before we do any modeling task, we understand that whatever column we have, are they connected to each other? Are they having or are they sharing any relationship between them? If they are, then we have to make some corrections. We have to take some preventive actions before we run any machine learning model on it. How we do it in Python is a very simple task. In Python, we have a simple function dot CORR. Okay. I apply the CORR or the correlation function on a data frame object df. So df.corr. Again, the CORR function will only work on your numeric columns. Okay, it will only work on the numeric columns. It will not work on your string data or object data. So CORR stands for correlation. It will return to you the metrics. Let's run that. If I print this, I should see something like this. So the correlation coefficient, though this is the numbers that you see, are called as a coefficients. What do they call as? Coefficients. Coefficients helps me understand how weak or how strong the relationship are between the columns. So if you see, this is n by n matrix. I have the same column headers. I have the same row headers. All the diagonal line you will see as a 1 because the relationship with passenger ID with itself is a highly correlated. Okay. So the range of output you will get out of correlation is -1 to +1. So what is the range of output? It is between -1 to +1. What does the values closer to -1 indicates? Anybody has heard before it or want to make a guess? What does the values closer to -1 indicates? Well, -1 clearly indicates that the two columns are negatively correlated. Two columns are negatively correlated. So if one goes up, second will go down. Okay. So in a very simple example, if the prices go up, my sales will go down. That is the negative correlationship. They have a relationship, but they have negative relationship. So the values which are closer to -1 indicates that the two columns are negatively correlated. The values which are close to 0, okay, the values which are close to 0 indicates that the two column has absolutely no relationship between them. Okay, the values which are close to 0 have absolutely no relationship between them. And lastly, what is the relationship that I can say if the values are closer to +1 or +1? Any idea? It's pretty straightforward, right? If I have the values close to +1, it simply says the two columns are positively correlated with each other. So if the value of one variable goes up, the second will also go up. The very simple example is if I increase the discount on my products, my sale will go up. So discount and the sales has a positive correlation between them. Are we clear, guys? What is -1? What is 0? What is +1? That is the range of output that you will get out of the correlation coefficient. Again, correlation coefficient helps you measure or quantify the relationship between the two columns. Right? Using this number, I can quantify how strong these two columns are. Are we clear, guys? Any quick question? Any confusion? This is the last topic for today, guys. So please help me understand if you have any question. You can say that, Sanjeev, no problem. So if the values are close to -1, you can say they are inversely related or inversely proportionate. Or if it is close to 1, you can say directly proportionate or directly related. However, the more statistical language is positively correlated and negatively correlated. That is the more correct language, I would say. But if the question is, can you use it? Yes, you can use the inverse and direct. No problem. Now, if I pass this table to my stakeholders, or if I pass this to my senior data scientist, maybe there is nothing wrong in it. The only problem is it is not demographic or it is not informative. I can just, I mean, I'll have to read the numbers, right? Imagine you are working on 100 columns. The very difficult part is how do you read these numbers, like 100 columns. So it will be 100 by 100 metrics. So in order to avoid that, we use something called as a heat map. So heat map is one of the plot which is available under Seaborn library. So sns.heatmap, and I provide this metrics as a first argument. The result that I get is something like this. It is again n by n matrix, right? Every cell has a number. So this diagonal, if you see, it is the positive one. Then I have said C bar is equal to true. So C bar is nothing but this color bar. So I've said true, so that's why I'm seeing this color bar here. Annotate true, so that's why I'm getting these numbers in the cell. If I say false, I won't see these numbers. Okay. Squared true, because I'm getting this image in the square. If I remove this, that's okay. If I remove this as well, if I run it, I don't get a square, right? It's not a perfect square. It's just more relaxed plot that I see. Next argument is FMT, which stands for format. And I'm just saying 0.2 fraction point. So I'm getting 0.2 decimal numbers everywhere. Is that clear, guys? So now, instead of looking these big numbers, I can just quickly look at the cells where I have a dark red color. Are you getting my point? So if you look at it, this 0.01, so this is minus 0.0. So passenger ID and Parch looks inversely related or negatively correlated. Is that clear, guys? What are we trying to do here? If you look at this Parch and SP, it is also having some kind of relationship in them. So instead of having this long table, right, which is very difficult to interpret to identify the relationship, I can simply put it under the heat map and try to identify if there are any cells which are very dark in color or very light in color. So if you see here, we are interested in the two values, either close to 1 or close to -1. So +1 indicates the lighter color, -1 indicates the darker color. So I have to look for those cells which are maybe very dark in color or which are very light in the color. So that's the same thing. Pearson correlation coefficient has a value between +1 and -1, where the 1 is total positive linear correlation. So that's a positive correlation. 0 is a no linear correlation. -1 is a total negative correlation. In the plot, we see there is no strong correlation between any two numeric variables. Are you all clear, guys? What is correlation coefficient? What is heat map? How you can utilize both of them together to make it more user-friendly plot to read the information. Yes, guys, are we all clear? The last part that we're trying to do is we're trying to identify the relationship between the column survived and the female passenger or the male passenger. So basically, just trying to identify what is the chances of survival based on the gender. So I'm simply doing df of sex is equal to male. So we have already done this, but let me show you one more time. Oops. Did I miss anything? No, I didn't. So I'm simply saying df of sex is equal to male. I'm just trying to put up a filter condition. If I put it this into df columns, I would get all the columns, or sorry, all the records where the sex is equal to male. I can select a specific column if I wish, survived. So I would only get one column that I'm interested in. So I just wanted to showcase this as a comprehension. So you can filter the records in one condition and you can only select one specific column that you wish to. And if I say dot mean, so I'm getting the average survived rate for the gender male. Okay, so I'm simply getting the average survived based on the column gender male. Similarly, I'm doing it for female, right? So if I simply say female and I say 74, right? And I'm simply putting it in the print statement. So the average survival rate for male is 0.18. The average survival rate for female is 0.74. So it is clearly visible from the data that the female passengers were in a luck and they had a better chance of getting survived. Right? So it is just another part of doing a data analysis. Right? We call this as EDA. I have used this term before. It's called exploratory data analysis, where I'm trying to understand the relationship between the survivedness and the gender. Are you all clear with this, guys? What we did here? Are we all clear? Quickly. How do we identify the average survival rate? Can you repeat how to interpret the heat map? Well, Akshata, if you look at this color bar, it is clearly visible that the value close to 1 would be in the light color and the value close to -1 would be in the very dark color. And these are the only two values that we are interested in, right? Because we want to identify set of columns that are either positively correlated or they are either negatively correlated. Is that part clear, Akshata? Any question on those part, this part? Any confusion on this part? Right? So in the color bar, we are just looking at the heat map to see if there are any cells where I have the color as a light, like 1, close to 1, +1, or is there any cells which is close to darker shade, like -1 or close to -1. So that's how you interpret. So you quickly observe this heat map, right? And we can clearly tell that there is no strong correlation that we can identify, because do you see anywhere like this color apart from this diagonal line? Can you see it? Do you observe any light color here in any part of the heat map? So that clearly tells me that my none of the two columns are strongly positively correlated. Can you even see any darker shade cell? Like this is -0.55, which is cool, which is good, but still not very close to what we are looking at, right? So instead of looking this big number, imagine this for 100 columns. Imagine we have 100 by 100 matrix. It is very difficult to look at every number, right? We have to go and check every column for that matter. But instead of doing that, I can simply put it under a heat map, and I can only look for those cells which has maybe a very light shade or very dark shade. Is it clear, guys? Any quick questions on heat map or maybe on the statistical significance? Because that was the end for the topic today. So we started with the very simple concept of central tendency, where we talk about three important parameters like mean, median, mode. We swiftly talked about the dispersion of the data, which generally helps us understand the distribution of our data, how good or how badly it is distributed. Then we swiftly talked about the describe function, which more or less tells you the 5-point or the 7-point statistical summary of every numerical column. And then we talked about the importance of histograms, which helps us understand the distribution of data, but visually. So I can use it this into my graph. I can use it this into my presentation or a case study when I want to tell the story of my data to my stakeholders. Or even I can understand the data from a machine learning task point of view. So in the next session, where we are going to start with the machine learning, I will tell you the importance of understanding the data well before doing any task. Because I have been repetitively saying, if you understand the type of data that you're working on, it becomes very easy for you to visualize what all actions you can take on that data. Okay, so now as I know my fair column is pretty much skewed, or it is pretty much not in a normal distributed fashion, I exactly know what I have to do on this column, right? Similar to that, we talked about the box plot, how you interpret the box plot. What are this line means? What are this smaller dot means? How are these outliers, right? Then we ended up with understanding what is the correlation coefficient and why it is important. Why it is important to study the coefficients in the well advanced, so that I can remove the columns which are highly correlated, because I don't want to pass the noise to my models. And this was just the last one, was just the flavor of EDA, or exploratory data analysis, to understand the relationship between the two variables. Right? Are we all clear, guys? Any questions, any confusions on whatever we learned today? Quickly, guys, any questions, any confusion, any doubts? Do you have now good amount of confidence in what is descriptive statistics, how it is interpreted, how it is calculated? Guys, any questions?
Yeah, Puneet. Hello.
Yeah.
Puneet, this line where we are finding out the mean of survived males.
Mhm.
Okay. So, I mean, how does Python interpret that we are talking about value one?
So we are not talking about value one, right? We are just saying mean. So what would mean do?
Oh, okay. Okay.
We are just talking about mean,
Yeah.
right?
Yeah.
I hope
Yeah, I
that
got
answers your
Yeah,
question.
yeah.
Okay.
Yeah, thanks.
Right. Any more questions, guys? Okay, I see there are no more questions. So again, repeat myself, guys. Please please go and fill the feedbacks as honestly as you can. because that will help us close the cycle, right? It will help us understand if we are delivering what is expected. So please feel the feedbacks as and when it is asked, and as you can be honest as you can, right? So Prathamesh say, do we use covariance? We use covariance at some end, okay? It's not that we don't use it. The only problem with the covariance is that, again, the problem between the variance and the standard deviation, right? The scale of covariance is very different, okay? That's why we directly do not happen to use covariance in any of the terminologies, okay? We use, that's why, either the coefficients or the correlation one. But covariance, and another difference I can tell you from my experiences, covariance biggest problem is you cannot quantify the relationship strength, okay? So covariance will give you weird numbers between minus infinity to plus infinity, okay? That's the range covariance will give you. But can you quantify that number as a strength of the relationship? That we are doing it in the Pearson correlation, because Pearson correlation gives me numbers between -1 to +1, isn't it? So that helps me quantify the relationship. I can say how strength or how strong or how weak is it. But in the covariance case, I do not have a quantified number. So that's why we don't use covariance in the industry. The biggest use case is all we have in the correlation itself. Yep, it is a very sharp formula. Yep, it is. So covariance, I mean, correlation has a very typical outrange, and it has a very typical unit which helps you quantify it. But covariance does not help you quantify this relationship. It will give you weird number, which is a very difficult to interpret. That's why we don't use covariance in a broader sense. There are hardly one or two instances that you might see people use covariance, but I have never came across. I hope I that answer your question. R square, yes, it is. It is in the linear regression. Yes, it is. It is one of the powerful parameters which helps you understand the performance of your model. Yes, it is. But apart from R square, there is something also we use is called adjusted R square. So R square is definitely there, but in industry, or I think in a general terms, what is more relevant is adjusted R square, not the R square. So you might, I mean, I'm sure you are studying it, that's why you know this concept. So you might want to just Google it. That is what is adjusted R square. Definitely we have it in the next session when we are going to talk about the linear relationship or the linear model. But yeah, you can read about the adjusted R square. There is a very fine line difference. Okay, it's not very huge difference between the R square or the adjusted R square. There is a fine line difference, but that fine line difference puts adjusted R square in the driving seat, and we use that more to understand if the linear model is doing good or bad. But that's, I'm really happy that you're reading this concept. Exactly. There are wonderful blogs available, guys, on the EDA. I don't know how many of you know a Medium portal, Medium blog site. I don't know how many of you know that. It's a very wonderful portal, guys. Just go there and read on the EDA. There are absolutely tons of articles, tons of blogs. People have written it, and it's really beautiful. You will get the real glimpse of it. All right. Yeah, you can simply go to Medium. I mean, there is this. Medium is the name of the blog. Let me share this. Let me share. So people across the world writes the blogs on a different topics. I don't know, people who are connected to me on LinkedIn, I shared two very interesting articles last week from the medium itself. You can definitely go and read on this. You will be amazed by the content that you will see there. Okay. All right, guys. So once again, thank you so much for joining in today. I hope the session was good. You learned at least few new things. In the next coming days, guys, keep practicing, keep reading, keep yourself busy with the coding so that you get more familiarized. Again, go and feel the feedbacks as and when it is asked. Let me know or let your course coordinator know in case of any concerns, any doubts you face. Take care of yourself, be safe. We'll again connect in the next week. Thank you so much, guys. Have a good day.